Okay, so you're in Internet, Web, and Cloud Systems is the name of the course now. It's got a regular number, 430, but it didn't make it into the catalog in time for them to actually change the number on the class schedule. So you'll see 410, 510 in a bunch of places. I've been trying to get rid of it everywhere. So really, the final number for this course is CS430, 530. So that is, sorry about the confusion. This was the last quarter that the 410 stuff will show up. So that is the link, and this is the syllabus. So everything about this course, all the resources associated with this course are linked off of that page. All the slides, the media space, the link to the media space. I screencast all the lectures. There's a link to the channel on that page. It's all there. The links to the code labs, the homeworks are all going to be there. So this is me. I'm Wu-chang, and these are my office hours, 9 to 11 o'clock on Tuesdays. The TA is Leslie Choi, and I'm really fortunate to have her. She has taken the course, TA'd the course, and taught the course, and is now TAing again. I decided to do something different. We used to teach this in a computer lab because there's just so much hands-on stuff for you to do. But in order to offer it to more people, we have it in a classroom setting. But it is extremely valuable to be there doing the labs with someone who has done all of them before. Because all of this cloud stuff is shifting all the time. You'll get crazy errors that you might not be able to figure out on your own very quickly. She should know. She's been through all of these labs a bunch of times. We decided to set up this optional lab section. Now, in order for us to reserve a room in this university, we needed a course on the books. So we decided to put 410L and 510L on the books just to reserve the room. But it's an optional lab. So that lab has 27 seats in it. So that's why we have all these crazy multiple sections of that, just to get that lab space. I really recommend that you go and you finish all the labs on that Friday in that section. Because you don't want to be stuck over the weekend trying to get labs done and running into issues that we could easily help you with. So that's the lab section that Leslie's going to run every week. Most of the time, the lab notebooks are due on Sunday night. So that is why I recommend this Friday section, especially the Fridays before anything is due, any lab notebook is due, for you to go and try and finish all of it before then. Right. So a little bit about this course. This is a tour of what I think are essential systems topics. Because I'm old, I can give you a little bit of a historical look at what we used to do. Like all of this, like the systems that have led up to this new shiny toy that we see as the cloud. I am also going to take a look at where we're going. Like, where is this transition that's happening from old school computing systems to the newer computing models? So we'll do a survey of the modern systems and the different abstractions that they are providing developers like you all. And then there's going to be a ton of hands-on practice using all of these things, from the lowest level nitty-gritty details all the way up to the highest level, write an app and deploy it to millions of people in an instant. So that will be what we're going to do, and it'll follow a logical progression. We're going to start with the lower level stuff just to show you how stuff gets built on top of lower level abstractions. And then you can see it's like turtles all the way down. There's like abstraction on top of an abstraction on top of an abstraction, and you'll hopefully get a nice view of the top all the way down to the bottom when you start deploying apps in the cloud. Okay, these are the course objectives. Understand at the lowest level how networking works and how it has enabled the cloud, the different parts of the networking stack that are involved. Perform web development and construct web applications backed by databases, so your initial Hello World app, because we need some kind of app to deploy to the cloud. We can't just deploy, I mean, it will be kind of a hello world, but we need something that will be like our Snapchat to like distribute to millions of people. And then we're going to use, get some practice with virtual machines and containers. And these are typically used as building blocks in the cloud. So we're going to look at how you would use these things to construct services. We are going to then adapt our applications to models of service that are supported by most of the cloud computing vendors. So, you know, what kind of abstractions and APIs do they have for you to be able to deploy applications? And then at the very end, if there's time, we're going to use cloud tools for data analysis and machine learning applications. So one of the nice things about the cloud is that it enables you access to a gazillion CPU resources and storage resources. So we're going to talk about back-end applications, things that don't have a front-end UI that people are using the cloud to leverage, large-scale jobs, for example. And this is sort of like data science and machine learning kinds of stuff that you'll find in our machine learning course. Okay, so about the course, this is actually intended to be an overview of our system electives. This is sort of where I would like people to start. And then because this course covers a lot of different topics, it's like a mile wide and an inch deep. And then to get a mile deep, you would want to take any one of these electives. So if you really love the networking part, and hopefully you haven't taken the electives already, otherwise you'll be pretty bored when we cover the section that's associated with this topic. So we're going to be doing a little bit of networking. So the networking class is 494, 594. A little bit of web development. Actually, that's 465, 565 that Katerina offers in the back there. Databases, 486, 586. Virtual machines and containers, it's sort of covered in 533, is where you would get a deeper dive into operating system stuff. The security course, so this is Charles Wright's course. You'll get a little bit of so we're going to have to do a little bit of security because one of the problems with the cloud is that it's completely insecure and it's super complicated, so people can't figure out how to secure it. So we have to do a little bit of this. And then data management. So cloud and cluster data management is more of the data science part in the cloud that Kristen Tufte and David Meyer offer. So if you have taken any of these, when you get to this point, it might be review. So hopefully you don't get too bored and we'll move on quickly. Okay, so some assumptions. Working knowledge of Linux, and I would imagine if you're all the way up here in the upper division, you probably have a working knowledge of Linux. If you are a new master's student and your program didn't do a lot of Linux, here are some resources that I would suggest for navigating Linux if you need practice. I like this one in particular because it's a game. It's a CTF game. And I run a bunch of CTFs in my courses, and I like that format for learning things. You need knowledge of processes and operating systems. And when we get to the operating system part, it'll make much more sense if you've had our version of CS201 or an operating systems course. Yeah. Oh. Yeah, go ahead and just fill it up then. You will need some knowledge of HTML. We're not going to do a whole ton of it, but you need enough to be able to submit a form. Like, you have to know enough HTML and I'll give you some code templates, but you need to have enough knowledge of HTML to be able to build basically a fairly simple application, or a willingness to watch a screencast or two to acquire it. So we do have some screencasts that cover some basic HTML, some basic forms, these sorts of things. Knowledge of Python. Or a willingness to work a lot outside of class to learn it. So that's CS161 is our Python class. You could learn it on the fly. When I come to the Python section, I will give you the parts of Python that are relevant to the course. I will try and give you the subset that you need, but it really does help to get a refresher on Python because almost everything, all the labs I've selected in this course are Python based, just so that you wouldn't have to learn a gazillion different languages, because in the cloud there's Go, there's Java, there's JavaScript, and then there's all sorts of languages you could use to deploy stuff in the cloud. I tried to make everything Python except for the ones that don't have a Python thing of like, there's some Node.js in here, just because there's no other way. Okay, the format. So this is the learning pyramid. I do quite a bit of lecturing, but of course the amount that you retain in a lecture is pretty minimal. So I try and follow all the lectures with a whole bunch of exercises for you to actually practice what I've just lectured on. So that is where all the lab assignments are coming from. I'll try and do a lecture and then immediately allow you to practice it. And you'll see towards the end of this course, I'll only have maybe like an hour or maybe even 45 minutes of lecture, and then the rest of the time you can work on the labs. So I would suggest bringing a laptop every class so that you can just, after the lecture is over, I can be here to help you get through any labs that you need done and navigate any of the issues you have. Okay, grading. So the percentages, rubric, and schedule are all on the course page. The breakdown of how much each part is worth. I grade attendance just to make sure that there's no exam. Anytime I don't have an exam in a course, I really require attendance so that I can be sure you're at least getting the information. I encourage participation both in class and on the Slack channel. We'll get to the Slack channel later. The bulk of the work in this class are the labs and the homework. For the labs, I want everyone to do their labs individually. You can work with others to complete them, but you, in the end, have to individually go through the actual mechanics. So you can help each other debug the labs, that's fine. Getting each other to a point where you can complete the lab is fine, but I just want to make sure everyone has at least gone through the mechanics. And the way I do that is to have you maintain a lab notebook, and this documents your completion of the labs that I have assigned. And I have you take screenshots that include your own Odin ID or the Google Cloud Platform project ID as part of lab completion. And you'll see in these labs where I have prompted you for creating those screenshots. And this allows the TA to see that you've actually completed the lab. And then I am going to collect these lab notebooks in parts. There are 4 big sections that I will collect the lab notebooks on. If you go to the D2L assignments page, you'll see that the due dates are already there, and you'll see that the course is organized in 4 big sort of sections, and these are the due dates here on the right. So I encourage you to make sure you get those on your calendar and not to let this thing sneak up on you. The homeworks that are going to be due also have their due dates up there, but I'll get to that later, and then there's a final project. Okay. So some of these labs have been moving targets in the past, meaning that Google did something and the lab doesn't work anymore. If you come through these labs and all of a sudden you're like, this doesn't say what it's supposed to say based on the lab code lab, more often than not, it's not your issue, it's Google's issue or our issue that we haven't updated the lab. I want you, when you get to that point, to send something onto the Slack channel. Because inevitably, if someone else has gotten that same issue and has figured out a way to solve it, then it can be done peer-to-peer rather than through me, because there might be a delay going through me. And that's what I'm going to encourage you to do. And of course, if you have submitted a fix to any of these labs, I have stuff I can give away. I collect stuff from like conferences and whatnot, and so I have a collection of things that I will give away for people who find bugs in these labs. And there's going to be a lot of them, unfortunately, but that's just the nature of continuous, deployment on Google's end. Okay. Homeworks. There will be some homework assignments, and these must be done individually. There are two programming assignments, and then one Docker container submission as homeworks. These are done individually, and I don't want you to share code or work collaboratively on the homeworks. The way homeworks are submitted is via code and container submissions. The code submissions are done over Bitbucket, and then the container submission is done via Docker Hub. We also want you to submit homeworks and labs, homeworks as zip files in the D2L Dropbox. Okay. And then the website has the rubric for the homework assignments. The final project can be done in pairs. So at this point, we do want you to practice collaborative development, so that will be done with the final project, or you could do it individually. If you really like your app and you don't want anyone else to touch it, then yes, go ahead, work on your own, go crazy. But if you don't really like your app and you like someone else's app, and there you don't mind using that as a basis for your final project, then you can work as a pair. I'm allowing that. But here's the catch. When we get to the final project, some of the requirements of the final project, as part of the requirements, we're going to ask you to integrate different APIs into your app. And if you have 2 people, you have twice the number of APIs to integrate into your app. So that's the catch for that. There are two deliverables for the final project. Well, there's 3 deliverables, actually, I should say. The first is that we don't have a final exam in this class. We just have a final demo. So during our final exam slot, we're going to all demo the final projects for each other. You're going to submit your URL for your final project, and then we're going to have hopefully 25 to 50 final projects, and we're just going to go down the list to just show what people have created for their final project. And that's an in-class demo. And then as a screencast demo and walkthrough, I'm going to have you screencast both a demonstration of your app and a walkthrough of all the code that you wrote to implement your app. And then this is going to be uploaded to MediaSpace the end of finals week. So you'll have all of finals week to sort of do the walkthrough of your final project. Okay. Late policy, and this applies to both the labs and the homework, 10% each day, and then no late work is accepted after 2 days. I close the D2L assignment after 2 days. And this is to keep the sanity of my TA, actually, because it's really hard for her to manage a whole bunch of different late assignments and to try and regrade them after the fact. So that is the policy. One thing that has gotten people a lot in the past is that they try and upload their notebook, and then they think it's been uploaded, but they fail to go back and download it again to make sure it actually got into the Dropbox. So if this thing somehow fails in the upload, you need to make sure that you catch that. Otherwise, to avoid deductions. Okay, the one thing I would like to note, if you have a heavy workload this fall, be aware that this class is a lot of work. It's a lot more work than some of the other classes that I personally teach. But if you are willing to put in the work every week and not fall behind, it's manageable. It's not like you'll get stuck for 5 hours on something in this class. It's predictable, the amount of work. Like when I say it's about 1 or 2 hours a week of doing the code labs, it's predictable. It's not like you're going to get stuck and then be stuck on something for 5 hours. That's not the way the labs in this class work. They're all fairly well documented, and you shouldn't have issues getting through it if you put in the time. Okay. So I'm going to start with the very first homework. So because there are a lot of moving parts in this class, the beginning homework is to set up a whole bunch of stuff. So that's homework number 1, and it's due as soon as you can get it done. We will see, based on the projects that we see shared with us, we'll see whether or not you've completed it. If you go to the website, you'll see that here in the assignments, you see part 1. Part 1 will give you everything you need to know about homework number 1. There's a bunch of slides that will walk through homework number 1 and all of the labs in the first section of the course. So all of these are in this single PDF. So you could work ahead if you wanted to. It's actually more helpful if you hear the lecture first before you go and do it. But especially if this stuff is review to you, you can go ahead. Just keep on going through these labs after you get to them. So if you click on that, you'll get something that looks like this. So this is the first section. So lab section 1. I just want you to go through all of this as soon as you can. A policy agreement saying that you're not going to cheat, and then sign it. All of the accounts. So create an account or join the Slack channel for this course. This is the unofficial departmental Slack channel or Slack workspace. So if you could join that, you can click on this and then join that channel. There's links off of the course webpage as well for you to do this. All of the communications, to me, I prefer done over Slack. So direct message me. If you send me email, I'll respond to it, but it'll be a little bit delayed, probably delayed. This is a much more effective way to contact me than email. If you have an issue anywhere in this class that happens and you would like to send me a message anonymously, that's my link. So any problems that you might have that you don't want to attach your name to, you can send it to me there. You need to create a Docker Hub account, so that's the link for that. And this is for homework number 3 for the Docker Hub. Okay, it is helpful for you to bring a machine to class every day that has Linux. And so I recommend installing a Ubuntu 18.04 virtual machine. There are directions, text file directions there. But you could just follow the slides, and then this is just a walkthrough of installing Ubuntu 18.04 on a virtual machine. So just download and install VirtualBox, and then download the ISO for Ubuntu 18.04, follow these steps, and then on the other side you'll have a virtual machine that you can use to do all of the work in this class. So that is the next thing. One of the things that you should do is name your virtual machine after your Odin ID. That makes it really easy when you're doing screenshots for the lab notebook to always include your Odin ID. So that would be what I would recommend for that piece. These are all different steps. For this virtual machine, I want you to install the Python pip and virtual environment. So we'll be doing a lot of Python in this class, so you got to install it. You also have to install Docker. So these are the ways to get Docker onto your virtual machine. And then if you like a better setup with your virtual machine, this is insert the guest edition CD image after you've installed your VM so that you can get full screen mode on your virtual machine. I don't know if you still need to do that, but I left that in there just in case it doesn't do that, because it's really annoying to have a virtual machine with a 640 by 480 window to work through. That doesn't work very well. Okay, there are some tweaks to VirtualBox that I recommend you doing, like a shared clipboard. Some VirtualBox display tweaks that I recommend. Making sure VTX is enabled on your virtual machine. That's really important. Otherwise, your virtual machine will be very slow. And then making sure that usually it is enabled by default on all laptops. But if your virtual machine is super slow, make sure that in the BIOS that VTX has been enabled. But that's the BIOS needs to enable it, and then the virtual machine settings have to enable it. And then hopefully 2 gigs of RAM. Most modern systems have at least that, so you would need about 2 gig to make sure the thing doesn't crater its performance on your laptop. Okay, the next thing is Bitbucket. So we are doing all the code submissions via Bitbucket. So I need you to go to Bitbucket and create an account. You can actually do this by logging in with Google and then doing Portland State single sign-on to it. That's the way I would recommend. Let's see. And then I want you to create a new repository. And in case you haven't had experience with Git before this course, the reason why we're doing this is because we want you to get more practice using Git. So if you're all old hat with Git, then this stuff will be a breeze to learn. But one of the things about this course for sort of developing your app and being able to submit changes to a Git repo and push it, we want you to practice those mechanics all the time in this class. And we'll actually be grading your use of Git in your homeworks. And you'll look at the rubric and it'll say, hey, Git repository activity. We're grading that. We want you in your workflow to get used to committing your changes so that you can use the tooling that's going to be expected of you when you graduate and get a job. So that's basically the reason why that's there in the rubric, just to get you acclimated to good software engineering practices. We want you to name your repository very specifically. This name, so we know whose repository we're looking at. And then we're going to have you pause. So after you create the repository, you get the account, create the repository, you're going to pause because then we're going to want to set up your Linux VM with SSH keys for you to bind your VM to your Bitbucket account. And that's what we'll do. So we're going to set up SSH key access to your Git repo. And this is what you'll do on your VM. You'll generate an SSH key. You'll copy the contents of your public key into the repository. And so you'll want to go to your repository. And in the repository settings, you want to add your SSH key. And actually, this is the wrong picture. Ignore that picture. This is actually an SSH key associated with me, not the project. I want you to associate it with the repo, not the person. I'll update these slides later. So then you would add an SSH key to this repository, and this will allow you to do something like this without submitting a username and password. So this allows you to do the pushes and the pulls to a private repository without having to enter in username and password on Bitbucket. It's just going to use your SSH key to authenticate. So and this is going to save you over the course of this quarter, hopefully an hour of typing in your username and password, which is really annoying. So that's why I have you do this. Okay. And then in your local VM, you're going to clone the repository you just created. You're going to add a bunch of files. So this adding, the committing, and the pushing. These are the basic commands in Git. So you're just going to navigate Git with that. And then what we want you to do is to invite myself and the TA to your Bitbucket repository. So these are the 2 email addresses you should use. Don't invite so the plus is a way of demultiplexing email accounts based on name. If you send it to my address at pdx.edu, you'll invite the wrong Bitbucket account. I have multiple Bitbucket accounts based on email addresses. It has to be that specific email address that you add in this step. And the same with Leslie. So we've been down the block before with all of these Bitbucket projects polluting our regular work. And so this is the way we're trying to separate our projects out from each other. Okay. If you are new to Git, I really like this tutorial. This is the one I started reading. Something similar to this is what I used actually to onboard with Git. And these are the commands I want you to really know for this class. And it's just a small number of them. Clone, add, commit, push, and pull. And you'll be using these all throughout this course to get code and to push it elsewhere. As part of the Bitbucket repository, I want you to create a file called .gitignore at the top level of your repository. And the reason is because there's all sorts of files that are going to be added to this repository that neither the TA nor I want to see. So when you do, for example, a virtual environment and you do a pip install, all of those packages get stored in that directory. And if you add that directory and then push it to Bitbucket, when we check your homework, we have to clone that entire distribution of packages that you have installed locally. And so the other thing is Python. Python is an interpreted language, but in order to get speed, it will do this just-in-time compilation. It'll try and compile all the way down to some kind of intermediate bytecode for performance. Those files are stored in these .pyc, this compiled Python, and then a bunch of package stuff gets stored in PyCache. We don't want to see any of that stuff, and the way Git will ignore that kind of stuff out of your repository is if you create a file .gitignore and you add those 4 things. So hopefully, when we do a clone on your repositories, we won't see any of that stuff. So that's why we have you do that. Then in that repository, you're going to create HW1 and then edit a markdown file. And so this markdown is similar to HTML, but we just want you to get familiar with that syntax. Create a Docker hub.txt file that's got your username in it. We don't want anything else in this file, so you could do something like this. So this is my Docker Hub ID. I could just echo it and then put it into that file.txt. And then I add and commit all of that stuff as part of homework number 1. And this is just logistical so that the TA and I can get at your stuff programmatically when we need to. Okay. The next thing is setting up a Google Cloud Platform account. So we're going to be doing labs on Google Cloud and on AWS. And particularly for the AWS stuff, I don't know if it's actually going to work. So it'd be helpful to know if that thing is going to work or not during the first homework. But we'll start with the Google Cloud. You can do one of 2 things. You can wait for me to send you a coupon, and then you can add a coupon to your pdx.edu account. If you're willing to, and that'll be a $50 coupon. If you are willing to put a credit card on your Google Cloud account, they have this free trial that will give you $300 as a coupon up front. But you cannot use my coupon first and then add the $300 one. They'll know. They'll say, oh, you're already a user of Google Cloud. I'm not giving you the $300. If this is your first time on Google Cloud and you like the $300 and you don't mind temporarily putting a credit card down, you can always pull it off later. Then you would do this. Click on this thing and then get your $300. And then I'm going to send you a Google Cloud coupon for 50. Did you have a question? Yeah. Oh. Ooh, so we should set up on the Slack channel a referral system.
You don't get money yourself unless they actually purchase like real credits.
Okay.
Use your link, get 350.
Ooh. Actually, yeah. So if you do that, the first person who does it, then you can send that referral, and then other people can use that link to sign up. Yeah. I have known people who have managed to get all the way through the cloud class with like $5 spent. So if you are really, and this is a skill, yeah. I'll get you more coupons, yes. Yeah. And in fact, I myself have left a virtual machine poorly protected up there, and it got compromised and was being used to send, it was being used to attack, do an SSH brute force attack on other people. Yeah, that's no fun either, because, and so here is the beauty of the Google Cloud Platform stuff, is that it's up to you to remediate any bad behavior that you have done to other people, either intentionally or inadvertently. There's actually one lab in this class that always gets someone in trouble with Google. And it's the Nmap lab. And when you get to this Nmap lab, there will be instructions to point the Nmap to an internal IP address. You should know what that is before you run that command, because it's gotten people, flagged for abuse almost immediately. Google sees that and says, why are you Nmapping external IP addresses? That's a big no-no in the cloud. But we'll get to that in 2 weeks, actually, or 1 week, actually. So I will be sending the course coupon over email, probably not until towards the end of this week, because I have to make sure I know the roster. I want to make sure the roster is set. Okay, and I want you to create a project called CS4, the same thing as your Git repo, should be named the same. And then the next one is an AWS account. So we are an AWS Educate institution, meaning that they like giving us free stuff. So as part of this, I created a course on AWS Educate. It's done through this third party called Vocarium. And the very first time I tried to do this on Vocarium, it failed miserably, and then we had to do something else. I'm trying it again. And I have set up a course, and the way this works, and I'm hoping this works the exact same way for you, I have a hard time as the instructor to get the student view of what you're going to be doing. This is theoretically how it should work, but I have no idea. So let me know if this is not anywhere close to what you see, because then I'll have to change all of this. When you go to this link that says, hey, you want to do a course view set to true, it will get you directly to this step 2 of 3. And you'll be like, hey, I didn't even do 1 of 3. Well, that's what this thing does. It gets you to this step. You type Portland State and then click on, we should show up as an institution. You click on that, and then magically, this drop down, there's only one course that I know of that's using AWS in this university. So we are the one and the only course that should show up when you select a course. So that should be our class. And then, so there, see? Then fill out, after you click on that, it'll give you a form to fill out saying, are you a student? And you say, of course I'm a student. I graduate in 2030 or something like that. Well, so maybe I should pause the video. So fill out the form with your information, and then it'll say thank you, and it will send you an email to validate that you own that email address that you said you had. Agree to the terms and the conditions. After you get that email, you'll click on something, you'll agree to the terms and conditions, you'll get the email, and then you'll click this link to set up your credentials. And then when you click over to AWS Educate again, you will get something that looks like this. So when you sign back into AWS Educate, you will get this, and over here in the upper right is your AWS account. You click on that thing. So there's this AWS Educate, which manages your requests for money. And then the AWS account is where the money goes to. And so that's what you'll end up doing. Follow the directions to log into your AWS student account. And hopefully, at the very end, you'll get something that looks like this. Okay? And this is the way you are to log into your AWS stuff. You log into AWS Educate first. Then you click on that AWS account, and then you connect in. And this creates on demand. This creates an environment for you to use the AWS services with. And it's an environment that's restrictive. Like, for example, you'll see that you only have access to one region, which is in Northern Virginia, and they only give you a very tiny subset of the full services that AWS has to offer. But that's more than enough for what we're going to do in this course. It's more than enough. So if you cannot get this, let me know immediately so that I can figure out what's going on. Okay. All right, so I'm not going to talk about the ARP labs. Are there any questions about the homework that you're going to be doing? Okay. No, oh yeah, so if you already are old hat with virtual machines and you have your own, in fact, if you have VMware already installed, don't bother installing VirtualBox. If you're, just as long as you're able to get a virtual machine up and down, you can use whatever you'd like. You shouldn't, what kind of virtual machine do you have already? Oh, you don't need a virtual machine. Yes, if you already, yeah, if you're running, and some people, if you're running a Mac, it's got Linux stuff, you may not, like, you have to navigate Python on a Mac. Yeah. If you want to go, like, I won't be able to troubleshoot anything for you, but if you really don't want to do any of the Linux stuff, then you could probably get by almost all of this on a Mac, or even, I mean, Ubuntu on Windows is there, so you could even do that instead of a virtual machine. Like I had Ubuntu on Windows 10, and it was basically Linux. And for all the things that we're doing in this course, it would work for that. So the blessed way that we will help you troubleshoot is the VM. But if you want to go off on your own, just as long as you don't need too much help with it, you can, yeah, go ahead. Yeah.
Is there anything to turn in for homework one, or just to complete all this?
Yeah, we'll see that you've turned it in by the policy agreement being in my hand, the Bitbucket repository, like getting emails from Bitbucket that says that we've been invited to your, yeah, so that's the stuff that we're going to be collecting for homework number 1. Yeah.
You have to put anything in the lab notebook?
The lab notebook's not due until like the third.
For homework one, do you need to put it?
Oh no, nothing in the lab notebook for homework. No, homework 1. Yeah, these are the screenshots are for the labs. Yeah.
On the slides it says due Thursday. Do I assume it's due next class this Wednesday?
This homework, hopefully you're done. Hopefully this homework is done by Thursday. Where does it say Wednesday? Oh, Thursday. Okay, next class is Wednesday. Yeah, I thought I was teaching Tuesday, Thursday. That's how discombobulated I am. It's Monday today. Okay, Monday, Wednesday. Yeah, so by next class. And, you know, this is, if you see how much this is worth out of the homework, it's very, very tiny. This is just, you can't go through the course without having done all of this stuff anyway. So it was just meant to get you to do it as soon as you can. Okay, so with that,